What's up, 7th grade? Mr. Agnos here, and this video is to help you with homework 7-3. I'm looking at question number 1. It says, identify the number of terms in the following expression. All right, an expression is just a mathematical sentence that doesn't have an equal sign. Okay, so notice that this expression right here doesn't have an equal sign. But what is a term? So I'm going to start off by writing a new example here, and then we'll get back to the one on the question. I'm going to say 3x plus 5y minus 2a plus 7. All right, so this is an expression. It's not equal to anything. There's no equal sign. And it's made up of 4 terms, right? And they're all connected by these plus and minus signs. You can think of the plus and the minus signs. These are called operators. These are connecting the terms together, right? So my operators are the plus and minus signs. But my terms are the 3x, I'm going to use a different color. That's the first puzzle piece, right? So I'll use T for term. I'm adding a 5y to that, so that's another term. And I'm subtracting a 2a, that's another term. And then I'm adding a 7. So this was a crazy T. This expression right here has 4 puzzle pieces, right? I got this first puzzle piece, and then I'm adding another puzzle piece, and then I'm subtracting another puzzle piece, and then I'm adding another puzzle piece, right? So we fill in these circles here with our terms. So this expression right here has 4 terms. So let's look at the one they actually give us. I'm going to rewrite it. It says identify the number of terms in this expression. I have a 3y plus 6m's plus 3, and using the same strategy here, we can see that, hey, my first puzzle piece is a 3y, my second puzzle piece is a 6m, and my third puzzle piece is a 3. So we have 1, 2, 3 terms. Remember, the pluses and the minuses, those are just what connect them together, right? So these are the 3 pieces that I'm adding. I'm adding a 3y, a 6m, and a 3. So I have 3 terms. Okay. Moving on to number 2. Number 2 introduces us to some new vocabulary. It says identify all the coefficients and constants of the following expression. So we have 2 new words here, coefficient and constants. So again, I'm going to start with my own example. I'm going to say 5x minus 3y plus 7 minus 2. So here I have an expression. It's not equal to anything. It has 4 terms, right? Here's my first term, my second term, my third term, my fourth term, right? You can see those terms right here. This time I'm doing it on top, but I got 4 things that are that's all being kind of stuck together using these subtraction and addition signs. Coefficients are the numbers being multiplied by the variables. Again, this is a very mathy term. It's just the number that we are multiplying our variables by. So I'm going to make a list of my coefficients over here. So my coefficients, all right, 5 is being multiplied by x. So that's my first coefficient. Okay, it's the number being multiplied by the variable. Here, we got to be careful. If there is a subtraction sign, we have to include that as part of our coefficient. So this is actually negative 3 times a y. So my coefficient in this case is actually negative 3. And the reason is we can think of this as 5x plus negative 3y, right? And so in this case, I think it's easier to see that, hey, yeah, negative 3 is being multiplied by y, and then we just simplify it to get 5x minus 3y. So there's my coefficients, right? The numbers being multiplied by the variables. And remember, if we're subtracting, we have to include the negative. Well, constants are even easier. Constants are just the plain old numbers that have no variables attached. So let's look at, so I'll make a list of my constants here. And let's start with 7. Now, the reason that these are called constants is because their value doesn't change, right? A variable, by definition, varies, right? Its value can vary. 7 is always worth 7, so it's constant. So my first constant is 7, and then just like with the minus sign here, if I'm subtracting a constant, then I have to include that as part of the value, right? So my second constant would be minus 2. All right, so coefficients are the numbers being multiplied by the variables. Constants are just the plain old ordinary numbers. Now, let's look at the example they give us. The first thing they want is the coefficient. Coefficient is the number being multiplied by the variable. There it is. So that's going to be an 8. You might have more than one. Notice it says is R, use commas. So if you have more, like I did here, then you would put 8, comma, and then whatever the other ones are. The constant of the expression, well, that's just the plain old numbers. So again, looking at mine, the only plain old ordinary number is 9. It's thinking, come on, it's 9. Got it. All right, moving right along. Let's take a look at number 3. All right, so why is this important to understand coefficients and constants? Well, it helps us to take complicated mathematical expressions like this and what we call combine like terms. So we started talking about like terms on the previous homework assignment. So an example of like terms would be like 8x plus 2x. It's like I have 8 x's over here, and you can actually literally imagine, x. Remember, 8x means I have 8 of them, right? X plus x plus x, so that's 4, that's 5, that's 6, that's 7, and that's 8. And then to my 8x's, I'm adding 2 more. All right, so I'm going to add 2 more. That's 9, that's 10. So I can combine these. Rather than having this 8x plus 2x, I can just say, well, that equals 10x. And we call that combining like terms. So we can do the same thing here. They want us to add 8 plus 3x plus 7 plus 2d. All right, the first thing that might throw you off is these parentheses. You don't need the parentheses unless we're actually distributing, right? So maybe we have like a 2 on the outside, and remember, then we have to go ahead and we have to distribute with our arrows and whatnot. But since we don't have a number outside our parentheses, we can actually just drop those. So I can rewrite this as 8 plus 3x plus 7 plus 2d. And they want us to add these together. Well, when they say add, they mean combine like terms, right? So what we're really doing here is we're combining like terms. So let's see what we have here that is alike. Well, I have 2 constants, right? There's an 8 and there's a 7. So I can definitely add those together. So I get 15. But I can't add x's with d's, right? Here I have 3 x's and here I have 2 d's. That's like apples and this is like bananas. Those are different things. So I just leave it. So my final answer is going to be 15 plus 3x plus 2d's. I can't do anything more to this. If this had been 2 x's, for example, then I could have said, well, 3x plus 2x is 5x, and I would have gotten 15 plus 5x. But because they're not, I can't do that. So when I go to write this, I'm going to say 15 plus, I don't know if the order matters. I think it'll accept 3x plus 2d or 2d plus 3x. Again, remember when you add 2 things, it doesn't matter the order that you add them in. Right? 3 plus 2 is 5. 2 plus 3 is 5. Doesn't matter. All right. I'm going to go ahead and set up number 5 for you. So let's take a look at number 5 here. But I'm not going to do it. I'm just going to set it up. It's a word problem. It says Val is going to plant N vegetable seeds in one garden. So that's our first piece of information. So we have N seeds in one garden, and we have 5N plus 2 seeds in another. How many seeds is he going to plant? So in other words, it's saying, well, we have to take this number right here, N. We have to add it to this number right here, and that tells us how many he's going to plant. So the way I would write this mathematically is N plus 5N plus 2. Okay, let's make sure we understand where this came from. This N is the number of seeds in this garden, and 5N plus 2 is the number of seeds in this garden. We're going to add them together. Well, let's look for like terms. I have 1N. Remember, if there's nothing in front of it, it's a single n here plus 5 n's. So I have 6 n's total, and then I have only the one constant. So this expression right here is the simplified form of how many seeds. Oh, I just did it for you, huh? I said I wasn't going to do it, and I did. This is how many seeds he has in total. All right, I'm going to do one more to help you out. I'm already at 10 minutes, and I know you guys have can only take so much math. This one I am only going to set up for you. It is number 11. An art class is making a mural for their school which has a triangle drawn in the middle. Anytime I get a problem like this with a shape involved, I'm going to go ahead and just draw a triangle. It says the length of the bottom of the triangle is x. Here's the bottom of my triangle, x. Another side is 4 more than 4 times the length of the bottom. Well, how would I write that? And it says another side, so it really doesn't matter which side. I want 4 more. That means I'm going to add 4 to 4 times the length of the bottom. 4 times the length of the bottom would be 4x, and then I need 4 more than that. So I would write 4x plus 4. 4 more than 4 times the length of the bottom. The last side right here is 14 more than the bottom. So if the bottom is x, well then this side must be x plus 14. What is the expression for the perimeter of the triangle? Well, remember, perimeter just means we're going to add up all the sides. So I'll set this up, but I'm not going to do it for you. I need to do x, that's my first side, plus x plus 14. That's my second side, plus 4x plus 4. So here is the one side of the triangle, here is the second side of the triangle, and here is the third side of the triangle. And you can see we have some like terms, and we have some constants here, so we can simplify this and clean it up. All right, guys, hopefully you find this video helpful. Make sure to ask lots of questions in class. See you guys soon.